Hey guys, so today we are going to be reviewing forces and motion. So you guys will have 3 different assignments this week, one from Monday, Tuesday, and Wednesday. So you will refer back to this video every time because all the information is going to be in this video. And then on Thursday, we're going to take our test for forces and motion. So make sure you're completing your work so you're getting good reviewing. So effects of forces. So first, what is a force? A force is a push or pull. You can also define force as a push or a pull on an object. So make sure you remember that. A force is a push or pull. So it starts an object moving. So here, if this first example, this soccer is being kicked by a force, and that force is the foot. It also stops an object from moving, so you can also stop that ball with your foot. It changes the speed of an object, so it accelerates the speed or deaccelerates the speed to make it slow down. So an example of making it slow down would be friction. And then it changes the direction of an object. So forces just, they either stop an object, start an object, change the speed of an object, or change direction of an object. So there are balanced and unbalanced forces. So 2 forces acting in equal and opposite directions, creating no motion, is a balanced force. So if you have 2 people pulling on a rope, like you have down here, if they are pulling with the same amount of newtons, they're both pulling with 50 newtons, then that they are canceling each other out so that they're not going to move and the rope is not going to move. But if one person is pulling harder than the other with more newtons, then the stronger force will result in movement in that direction. So a tug of war game can show balanced and unbalanced forces because if the rope is not moving, the teams are pulling with the same force, which is balanced. If the rope is moving, one team is pulling with more force, so that would be unbalanced. So now we're going to talk about gravity. Gravity is a force that pulls an object towards another object. So we've always talked about that a force pulls an object towards the Earth's core is called gravity, but it also happens within our planet. So a force that pulls an object towards another object, there is gravity between the sun, the Earth, and the moon. So one of your questions this week for Monday's assignment says, if gravity were to suddenly stop, predict what would happen to the motion of our planet. So if there is no push or pull between the Earth, sun, and moon, what do you think will happen to our planet? So next we're going to talk about mass versus weight. So these are 2 different things. Mass is just the amount of matter that thing has, but weight incorporates gravity. So weight is gravity combined with mass. So weight can change if you're on the Earth or if you're on the moon or if you're on another planet. Since the gravity changes, the weight will change, but the mass will stay the same. And you can see that in this chart. A book's mass on Earth and on the moon is 1 kilogram, but a book's weight on Earth is 2.2 pounds, and on the moon it is 0.363 pounds. So the planet or the place with the most gravity, the weight is going to be larger. So if we had a larger planet and it had more gravity, the object is going to weigh more there. So how are mass and weight affected by different gravitational pulls? So like I said, different gravity impacts the weight, but it does not impact the mass. So mass is not affected by gravity. The mass always remains the same. The weight changes based on where it is located. Okay, next one. So next we're going to talk about friction. This is a really important part of our unit on forces in motion. Friction is a force, but it is a force that slows things down. So friction is a force that slows down an object that is rubbing on a surface. So you can also define this as a force that slows down the movement of an object that is moving in the opposite direction is called. So friction acts in the opposite direction of the object's movement. So some examples of friction are static. It keeps an object in place. Sliding, two objects sliding against each other. Rolling, an object rolling on another surface. Or fluid, objects moving through liquid or gases. So if you have two surfaces, so if we have carpet and then we have like tile, carpet is going to have more friction. So if I roll a ball on carpet, it's going to go a lot slower and a lot shorter distance than if I roll a ball on tile, because the tile has less friction. So we're also going to talk about air resistance. So air resistance is a type of friction. It's a type of friction that slows objects down in the air. So you have a picture over here of someone skydiving with a parachute. The parachute has come undone, and that air resistance is slowing the object or the person down. So air resistance is a type of friction. So why is air resistance sometimes useful? It allows humans to parachute safely to the ground. It allows humans to fly kites. It slows down planes so they can land safely. So if you imagine, if you throw a little feather up in the air, that feather is going to come down slowly because of air resistance. Next we have momentum. Momentum is the strength of something when it is moving. Objects will continue to grow stronger and faster as time passes. The more mass something has, the more momentum it has. So we have talked a little bit about this in Newton's laws. So the yellow bowling ball will have more momentum. It has more mass than the red bowling ball. All right, so Newton's first law of motion, the law of inertia. So Newton's first law of motion is also called the law of inertia because an object at rest will stay at rest, and an object in motion will stay in motion with the same direction and the same speed unless acted upon by an unbalanced force. So this is also called inertia. You can also define inertia as an object at rest tends to stay at rest, an object in motion tends to stay in motion is called inertia. So an asteroid will move the same direction and same speed unless a force acts upon it and changes its speed or direction. So if you roll a ball on a surface that has zero friction, no friction whatsoever, that ball will continue to roll and will not stop unless acted upon by an unbalanced force, unless that unbalanced force is friction, unless someone stops it with their foot. So if you roll a ball on zero friction, it's going to go on forever. And so that's the part where it says an object in motion will stay in motion. An object at rest will stay at rest. If I lay my cup on the table, my cup is going to stay there forever unless something happens, unless an earthquake knocks it over, or somebody knocks it over, or if I pick it up. So next we're going to talk about speed, velocity, and acceleration. You don't really need to know much about velocity, but speed and acceleration are important. So speed is the amount of distance something goes in a time period. So that's why we calculate speed with distance divided by time, because it's the amount of distance something goes in a time period. Velocity is just speed with direction, and acceleration is gaining or increasing speed. So when you start to increase speed, that's acceleration. And I know we've talked a little bit about that on the distance time graphs, where you can identify which line is acceleration or increase of speed. So to calculate speed, it is distance divided by time. We've already went over this, these same questions, so I'm not going to go over them again. But all you're going to do is take the distance and divide it by the time to find speed. Next is Newton's second law of motion. Newton's second law states the greater the mass of an object, the more force it will take to accelerate the object. To calculate force, multiply the mass by the acceleration. So what you really need to remember for this is it's going to be harder to stop and start an object that has more mass. An object with less mass is going to be easier to start and stop. So it takes more force to actually move an object with greater mass. And you can just think about that. If you're trying to move this big rock like this guy is, and then maybe if you had another person who was trying to move a smaller rock, it's definitely going to take more force to move that bigger rock. So if you push a boulder and a rock with the same force, what will happen to each? So the rock will go farther than the boulder because the boulder needs more force to move it the same distance. So position, distance, and direction. Position is the location of an object. So on Tuesday's assignment for your vocab on the Monday part, position is actually one of your vocab words. And that would just be an object's location, or the location of an object. Distance is the amount of space between two objects. So you have that as a vocabulary word too, and the definition is very similar to this one. And then you have direction, the course something moves along. That is not one of your vocabs, so I'm just going to skip over that. What fun way are you going to use to remember how the order of the cardinal directions? And we can skip to this too. Next, we're going to talk about motion time graphs. This is also called distance time graphs. So a graph that shows the motion of an object or the speed of an object. So when you have a flat horizontal line, that means no motion. That means the person has stopped or the object has stopped. Next, if you have a straight diagonal line in any direction, it can cross over the other way too. That means constant speed. So a straight diagonal line is constant speed or steady speed. When you have a curve that's moving up like this, that's acceleration. That means that object is accelerating. And then we have deacceleration. So that's when that curve is moving down, and that means the object is slowing down. And I want to look at constant speed because I know you're going to get some questions on this. They're going to say, what's happening in this graph where it says constant speed? A lot of you would probably put, if you weren't really thinking about it, you'd probably think the speed is increasing, but it's not. Just because it's going up like that, that does not mean the speed is increasing. Because you have to think about, if you go to any of those points on that line and calculate the speed, it's going to be the same all the way from the bottom all the way to the top. That speed is constant. The only time that the speed is increasing is when you see a curve in the graph like the acceleration one. Oops. Next, we have force and its effect on motion. We're going to skip over this too. We're going to go over the chart. So let's look at what happens when the force increases. So if you have a larger force on something, the speed is going to increase and the distance it travels increase. So the greater the force, the greater the acceleration there will be. So the greater the force, the speed is going to be up and the distance is going to be up. Next is mass and its effect on motion. So which is harder to move? The bowling ball? Oh, these two. You have a soccer ball and a bowling ball. So which is harder to move? The bowling ball would definitely be harder to move because the mass is more. Why? Because it has more mass. So the more mass, the more force that is needed to actually move the object. So now we're on to Newton's third law. For every action, there is an equal and opposite reaction. So explain how this law relates to a rocket ship. So you can see over here, when they blast from the rocket ship, all of that fuel, all that jet fuel is pushing down, which pushes the rocket up. So hot gases push on the ground from the bottom of the rocket, which causes it to go up. So there are equal and opposite reactions. And that is our last page for our slides. There's just a few things I want to go over with you before you start your homework. Some things that might not have been on this. So just quickly, you need to know force, motion, gravity, friction, mass, and inertia. We went over those. So what gravity does to keep our planet in motion. So we talked about how there is gravity between the moon and the sun and the earth as well. We also need to know forces used when soccer ball is kicked in the air. So when a soccer ball is kicked in the air, there's not only an applied force, there's gravity that brings it down, and there's friction that brings it to a stop. That's materials for a water slide. So think about materials with really low friction. On Tuesday's assignment, you need to know speed, distance, time, momentum, position, and acceleration. We went over those. And on Tuesdays as well, if you look at Thursday's assignment, you're asked to find the time. So to find the time, you're going to do distance divided by speed. So remember that on Tuesday's assignment, you're on the very bottom question, you're going to be asked to find time or how long it will take you to get there. From the highway you choose, you're going to do distance divided by speed. And then on week 3, we have the distance time graphs, and we went over those. So that is all I have for you guys for this week. Make sure you guys are studying and doing your best. Thank you.